So remember right at the beginning we said that the only things that exist as little atoms on their own are the noble gases. But sometimes you can have, like for instance, a piece of copper metal. It's pure, it's only copper atoms in the metallic bonding. But how do you know that there's only copper in there? Because for instance, if I give you a piece of steel, you don't necessarily know if there's other atoms in there, because it looks like it's pure, but meanwhile you've actually got iron and nickel and chrome atoms in there. So at the end of the day, it's not possible to distinguish between elements and compounds by their appearance alone. I mean, when you look at a glass of water, you can't go, hello, I can see some hydrogen atoms and some oxygen atoms. So the basis of chemistry is conducting experiments, okay? So if you have a chemical reaction and it produces something that you can't break down, that is itself an element, then you know there must have been a compound, okay? So you can have decomposition reactions and synthesis reactions, and we'll talk about that a bit more. But there's decomposition and synthesis reactions. But if you break a compound down and it produces an element, then there must have been a compound made up of those specific elements. So the example that they give you that you're supposed to know about in the CAPS document is the electrolysis of water. So if you have liquid water in a jar, see here as part of this is a schematic diagram of this. If you have water in a jar and you use a battery to supply electrons, which is a source of energy for this reaction, okay, you can actually split water into hydrogen gas and oxygen gas. So the battery provides electrons, and the electrons kind of chemically attack this bond between the hydrogen and the oxygen atoms, and they break the bond between the hydrogen and the oxygen atoms, and you produce oxygen. Here's the one reaction. These are two half reactions showing you. You remember the battery is pumping electrons out. So the flow of electrons is in a circle. So the one is producing electrons and the one is accepting electrons to make a circuit. So don't worry too much about these two reactions. Here, the two half reactions. It's just showing you where exactly the electrons are going. So, but this water molecule is split up, and it splits up into oxygen and hydrogen. And now remember, the oxygen atoms are not happy on their own, so they form the diatomic O2 gas. The same with the hydrogen atoms. They don't have a full shell, so they bond with each other to form diatomic hydrogen gas. And one of the most interesting things about this experiment, if you do it, is that when you watch the test tubes filling with gas, the hydrogen column is always double the volume of the oxygen column, and that's to do with this ratio of elements here. So it was experiments like this, the electrolysis of water, that led scientists to realize more things about the fixed ratio. As well, when you combined things, sometimes you could put, if you react two things together, you can keep chucking one compound in, and then sometimes you've got too much, it's not working. And that's when they realized that there's a ratio between elements. So now you've got two colorless gases coming out here. You actually need to test for them, because, I mean, I could tell you this was chlorine and fluorine. How would you know? Well, obviously the first thing would be, if these really were chlorine and fluorine, your nose would be on fire. So we have what we call tests for gases, and I think you've seen the test for carbon dioxide, because you talk about it with photosynthesis. When you bubble carbon dioxide through lime water, the lime water goes cloudy. So now the test for hydrogen is that you put a glowing splint in the test tube and you hear this funny little squeaky pop noise, okay? Hopefully we can do this in the class, squeaky little pop noise. But if you test for oxygen, you have a splint that's not got an active flame on it. It's just red and glowing, you know, like coals glow in a fire, charcoal when you braai. So this splint is glowing like that. And when you put it in the oxygen, it bursts into flame again, okay? The glowing splint will relight. The same way when you blow on coals, sometimes you can get flames out of them. Because in actual fact, when you're blowing on the coals, you're putting more oxygen and then you get fire. So this is one of the ways that they can tell that water is a compound, because we can split it up into two elements, which you can use for other things. So if we're going to test for hydrogen in the lab, this is what we would do. We would have hydrochloric acid. HCl is hydrochloric acid, and some zinc metal, and then you chuck it in there, and then you can see the bubbles of hydrogen gas form, because everybody's like, bubbles of gas, it's carbon dioxide. No, calm your jets, grade 10. Bubbles of gas are not always carbon dioxide. Sometimes the bubbles of gas are hydrogen. Okay, so that's why we have all the gas tests. Why can't they be carbon dioxide? Because there are no carbon atoms on the left, so there can be no carbon atoms on the right. So the hydrogen atoms form hydrogen gas. Well, these are actually hydrogen ions and a chloride ion. And then the zinc loses electrons and it forms the zinc salt. So we're going to talk about general reactions later that you must learn. One of them is a metal plus an acid, gives you a salt and hydrogen gas. And this is how we make hydrogen gas to test for it. So while we are on the subject of testing for gases, these are the 3 gas tests that you need to know. Then you just have to know them, but I don't know, they just pop up randomly. They're not in a specific place in the curriculum, so now's as good a time as any. So if you test for oxygen, the glowing splint bursts into flame in the presence of oxygen. With hydrogen, a burning splint causes a pop when it comes into contact with hydrogen. This is actually the explosive formation of water. The hydrogen mixes with the oxygen in the air, and then it forms water, and it's a strongly heat-producing reaction, and it makes a pop noise. And then you've hopefully seen the test for carbon dioxide. If you bubble the gas through lime water, the solution will turn milky. This turning milky is what we will now call forming a precipitate. We will talk about forming a precipitate very shortly, not too far in the future. So these 3 tests for gases you're supposed to know and learn them, so that if somebody says that, you know, this is the gas that's been formed there. Okay, and that's the end of this section. We'll move on to another section at another time.